The lesson topic of this video is area, volume, and perimeter applications. So what we're going to talk about here is we're going to talk about three geometry concepts, area, volume, and perimeter, and we're going to apply those to the polynomial work we've been doing the last few days. So the directions read, write the perimeter and area of the figure as a polynomial in standard form. The first thing I want to remind you is that what standard form means is that we always write it with our variable with the largest exponent first, and then so on all the way down to our constant. So for example, if I had an x to the fourth plus 3x to the third minus 2x plus 7, that would be written in standard form because our highest exponent on a variable comes first, and then x to the third, and then x. We have no x squared term in this one, that's fine, and then ending with our constant. So standard form. Alright, so we have to use some geometry knowledge in this lesson. And this first one, we have a triangle. Notice that we have a couple of tick marks here. Remember that from geometry. We have congruent symbols. So we know this length is congruent to this length. And we have a right angle right here, which might be important as well. So if I want to write the perimeter of this figure, we have to remember that perimeter simply means the distance around the exterior of the figure. So I always talk about if I was going to walk the perimeter of the figure. Alright, so if I'm starting up here at this point and I was going to walk around this figure, I've walked 6x units. Oops. Alright, let's try that again. 6x. And then I've walked from there across here, so 5x. Plus, then I also have to walk from here all the way up to here to get back to where I started. And notice, because of the tick mark saying this is congruent to this, we know this length is 6x. It is not 2x plus 4. So another 6x. Now, we've been talking about polynomials, and now what we want to do is we want to make sure to combine any like terms. So we have 6x plus 5x plus 6x. They're all like terms, which means this will be 17x for our perimeter. Alright, now let's talk about area. Area of a triangle is 1/2 times the base times the height. So we're going to go ahead and fill those in. So area equals 1/2 times our base, and our base is 5x, times our height, and our height is 2x plus 4. Now you can see here why this is going to be applied to our polynomial work. We need to multiply 1/2 times 5x times 2x plus 4. Now, I have a recommendation here. My recommendation is that we do not multiply 1/2 times 5x first. Remember that multiplication is commutative. I can multiply these three factors in any order I want. So I'm first going to take 1/2 of this here instead of the 5 because that will make, give us a decimal, which is fine, but I'm going to avoid it. So area equals, I'm going to take 1/2 and I'm going to multiply this 1/2 right here by all of this. So 1/2 times 2x is an x, half of 2 is 1, and then half of 4, so half of 4 is 2, so plus 2, and then I still have 5x. Now to multiply these, I need to distribute the 5x. So I'm going to multiply this 5x times x and multiply this 5x times 2. So area equals 5x times x is 5x squared, and then 5x times 2 is 10x, so plus 10x. And this is in standard form, and it's done. Go ahead and try this second example, knowing that this is a parallelogram. And remember that parallelograms have opposite sides congruent, so that's something you might want to remember. And try to write the perimeter and area and then check back to see how you did. So the perimeter is the distance around, so I'm going to start here. I'm going to add 9x plus 7 plus 6x plus 6 plus this here, which is congruent to 9x plus 7, so 9x plus 7 plus my last side over here, which is congruent to this, which is 6x plus 6. Now combining like terms, we have 9x plus 6x plus 9x plus 6x. So that will give us 30x. And then we have 7 and 6 and 7 and 6, which is 26. So plus 26. And there is our perimeter. The area formula for a parallelogram is base times height. So the base is 6x plus 6, and the height is 10x. Again, we're just going to distribute then. We have a binomial, 6x plus 6, and we have a monomial, 10x, so we can distribute that 10x to both of our terms. So area equals 60x squared, because 6x times 10x is 60x squared, plus 60x, because 6 times 10x is 60x. Okay, so now this example asks us to write the volume of the figure as a polynomial in standard form. We do provide the volume formula right here for a rectangular prism. Volume is length times width times height. So I'm going to go ahead and write volume equals length times width times height right here, and I'm going to fill in what I know. The length is 2x minus 1. The width is x, and the height is x plus 2. Now notice, if you would have put the length in as something else, like x or x plus 2, it would have been fine, because we are multiplying these three things, and we can multiply them in any order, so it doesn't actually matter which one you put in for which variable. Now to simplify this, we have to multiply 2x minus 1 times x plus 2. And again, I want to remind you they can be multiplied in any order, so whatever you're most comfortable with is fine. So for example, I could multiply our first two factors here, 2x minus 1 times x, and when I do that, I'm going to distribute this x like I showed on the previous screen, like this. So 2x times x is 2x squared, and x times negative 1 is negative 1x, or just negative x. Now that is our new binomial right there, and I want to point out that we do not also distribute the x this way. We do not. We already multiplied it into this set of parentheses, which means it is in here, it's multiplied into there. So now if I multiply the 2x squared minus x times the x plus 2, that x is already now being multiplied by this because it's within this term right here, or factor. So now what do we have to do? We have to FOIL. And again, if you like FOIL, use that method. First terms, outside terms, inside terms, last terms. But if you're more comfortable with that chart I showed or matrix that I showed in class the other day and in the lesson, you can go ahead and use this as well. So we have 2x squared, and we have minus x, and we have x plus 2. So again, I put this here, put this here, the x goes here, and the 2 here. Now we're going to multiply each of these. So multiplying 2x squared times x is 2x to the third, and 2x squared times 2 is 4x squared, and negative x times x is negative x squared, and lastly, negative x times 2 is negative 2x. And again, had you used FOIL, we'd have the same answer. So we have 2x to the third, and then we have negative x squared and 4x squared, which gives me plus 3x squared. And then we have minus 2x. And that is our volume in standard form. The last example, again, I'd like you to write the volume, just the same directions as the last screen. Write the volume in standard form. So the volume of a cone is 1/3 times pi r squared h. Give you that right there. Because it's 1/3 of the base of the cone, which is a circle, so pi r squared, the area of the base, and then times the height. So I'm just going to rewrite this as 1/3 times pi times the radius, which is x minus 2, times the height, which is 2x plus 1. Now, we need to simplify this, and I think the easiest thing right now might be to actually FOIL this first. And again, FOIL or use the matrix method I showed you again on the previous screen. So for x and negative 2 and 2x and 1, we get 2x squared, x, negative 4x, and negative 2. So now we have volume equals 1/3 times pi times 2x squared. That's this. We've got negative 4x and x, so negative 3x. And then we've got minus 2. Now at this point, we can just distribute the 1/3 and the pi together into each term in the parentheses. So I can take this factor and I can multiply it throughout the parentheses, and we can leave pi as pi, so in terms of pi. So 1/3 times pi times 2x squared. Now I'm going to write that all out just to make sure you understand what's going to happen here. So 1/3 times pi times 2x squared. And then this minus sign I'm going to bring in here, minus 1/3 times pi times 3x, and then this minus sign, minus 1/3 times pi times 2. All right, so right here in this term right here, we're going to simplify this. Now all you have to really think about is that 1/3 times 2 is 2/3, because it's 1/3 and 1/3, so that's 2/3. So volume equals 2/3 pi x squared. We can leave it in terms of pi. Minus, now 1/3 times 3. Well, what's 1/3 of 3? Well, it's 3/3, or just 1. So we get 1 times pi times x, and we didn't need the 1, but I put it in there. And then minus, again, 1/3 times pi times 2. What's 1/3 times 2? So we're saying 2 1/3. If you think about like baking, you need 1/3 of a cup times 2, so you have 2/3 of a cup. So 2/3 pi. This is our final answer. That one does seem a little bit more complicated because of the pi, but just remember you're just distributing the 1/3 and the pi into the parentheses.